But just sound basic vocab, an experiment. And that's just some process that occurs with all defined outcomes. So, flipping a coin. You're flipping a coin and you're seeing what the coin lands on. That's an experiment. Okay? You're doing an action and you're seeing what the outcome is. Okay? An outcome is just a result of that experiment. So, let's just go back. Our experiment is flipping a coin. Okay? And the outcome is landing on heads. That's what happens when we flip the coin. Okay? It's a result. An event is a collection of one or more outcomes. So you might flip the coin 3 times. Okay? And it lands on heads 2 of those times. So the event is seeing how many times it lands on heads. It's giving criteria to your outcome. Okay? And we generally take the probability of an event. So you might say, what's the probability of landing on heads? That's the event. Sample space is just a collection of all the outcomes of the experiment. So when you flip a coin, what are your possible outcomes? Heads or tails. So your sample space is just heads or tails. Okay? Because those are the possible outcomes. That's what your coin can land on. So the basic definition of probability, and then my fraction bar didn't want to convert here, is when you have an event occurring. Finding the probability of an event occurring is this ratio, which is defined as N of E is just the number of outcomes that fall into an event. So if we try to find what's the probability of the coin landing on heads, okay? However many outcomes there are of landing on heads goes in the top. The sample space, so the amount that is in your sample space goes in the bottom, okay? So it's the total number of outcomes goes on the bottom. The number of outcomes that fit into the event you're finding the probability of goes in the top. Okay? All probabilities must fall in between 0 and 1. So if you are doing a probability question and you're getting a number bigger than 1, you're wrong and you need to fix it. Something happened, more likely you maybe did your fraction backwards, you flipped your fraction. Okay? But probability should always be between 0 and 1. Or if you're getting a negative answer, you can't have negative probability. So again, you might need to go back and fix something. Okay? You can have a 0% chance of something happening. You can have a 100% chance of something happening. That's fine. You just can't go outside those 2 numbers. Okay? Anything in between is fine. Okay? Questions over this? Probability is always between 0 and 1. So, with that logic, which of the following cannot be the outcome of a probability? A, B, C, or D? C. Yeah, why is C not a probability? Yeah, 3/2 is more than 1. If you aren't sure if a fraction is bigger than 1, convert it to a decimal. 3/2 as a decimal is 1.5, and 1.5 is bigger than 1. Again, we said 100%, as long as the percent sign's there, okay? 100%, that's possible. Okay? So that's fine. If it just said 100, no, you can't have 100. Okay, but 100% totally fine. Questions over that? Well, we take a look at this example. It says a spinner is spun around a circle with 5 equal sectors that have been marked off as shown. What is the experiment here? What action are we doing? Spinning a spinner. That's our experiment. We're spinning a spinner. That's our action. So that's our experiment. We're spinning a spinner and trying to see what number it lands on. So write out the sample space. And again, sample space is all the possible outcomes. Well, what are all my outcomes? What could the spinner land on? It could land on 1, right? What else could it land on? 2. It could land on a 3. It can land on 4. It can land on 5. Can it land on 6? No. So 6 going to be in our sample space? No. It can't be. It's not a possible outcome. There's no 6 on that board. Okay. What's one outcome? 3. Again, an outcome is just something that your spinner can land on. Your spinner can land on 3. 7 is not going to be an outcome because it's not in your sample space. D is saying, what is the probability of landing on a prime? So whenever you're asked to find probability, you're going to make a fraction most of the time. Okay? And using that definition we just talked about, the total possible outcomes goes in the bottom. How many total possible outcomes did we have? 5. Go to your sample space and count. 1, 2, 3, 4, 5. We had 5 total possible outcomes. Of those outcomes, how many are prime? Very tricky. Very careful. Well, let's go through what I like to do. Circle my prime numbers. What are my prime numbers in my sample space? Very careful. It's one a prime number. One is not. We all think it. One's not prime. Okay? One is not a prime number. It's a special case. Okay? But technically, one is not prime. Whenever it asks for what's the probability of landing on prime, one is not prime. Okay? So is 2 prime? Yes. Is 3 prime? What's the definition of a prime number? Only what? 1 and its self are factors. It can only be multiplied by 1 in itself. So is 3 prime? Is 4 prime? No, because 2 times 2. 5 is prime. So how many in our sample space are prime? 3 out of 5. What's 3 out of 5 over 5 as a decimal? 0.6. Okay. If you left it as 3 out of 5, that's totally fine. Because for practice sake, I like to write them as decimals. Always see they're not very sticky. You can leave an unsimplified fraction as your answer. As long as it's the right unsimplified fraction, you still get full credit. Okay. But just for practice purposes, I like to set it as a fraction and then write it as a decimal. Questions over that? If we look at the next example, it's just finding basic probability from a table. Okay? So whenever it's written in this notation, you have like a capital P with parentheses and something inside those parentheses. That just means, hey, find the probability of someone getting an egg. Find the probability of picking a male. Find the probability of picking a female. That's what that's saying. Okay? And when we're given a table, we're trying to find probabilities from a table. Sometimes we're given the totals. Sometimes we're not given the totals in each column. So when that happens, what we're going to do is make our own total columns. Just so we have them and our work is organized. You just kind of have to extend your table a little bit. Okay? And let's find the total for male. So to find all the males, you add up across or in the male column. So 15 plus 20 plus 13 is what? 48. To find the total females, you just add across 12 plus 19 plus 9, which is what? 40. Okay? To get the total amount of people who got an A, you do 15 plus 12, which is 27. For B, same thing. How many people got a B? And then how many people got a C? Okay. To get the total overall amount, how many students did they survey? In the directions, how many students did they survey? 88. So that's what's going to go in the bottom. Sometimes it doesn't tell you in the directions how many students or how many people were surveyed, how many total outcomes there are. So when that happens, we have to add up to find our own. What happens a lot of the time when we find the total, the overall total, I see students add all the endpoints up. You don't do that. You only add one side up. Okay, because we're adding all the endpoints up, you're counting for 15 2 times. Because 15 was added here, and 15 was added there. So you're going to get double of what should be there. So you just kind of pick one side. I always pick this side. Okay? I'm just going to add 40 and 48 together, and that gives me 88. That gives me my overall total. The bottom part should also add to 88. So when we do 27 plus 39 plus 22, that should also equal 88. Okay? But you don't add all the endpoints up. Okay? You can add everything in the table up, and it will give you 88, but you don't add the ends. Okay? Because you'll double count things. and you get too big of a total. Be careful with that. Okay. So here it just wants to know, find the probability of getting an A. So make your fraction. What's going to go on the bottom of our fraction? What was the total? 88. Of those 88 people, how many got an A? 27. So 27 goes in the top. Plug that in your calculator. 27 divided by 88. What do we get when we do 27 divided by 88? 2 decimal places. Always round to 2 decimal places. 0.31? 0.31. Just for practice sake, again, this 27 over 88 is totally fine. 0.31 is totally fine. Just for practice sake, what's 0.31 as a percent? What is 0.31 as a percent? 31%. Okay? You multiply it by 100 or you move your decimal place over twice. You get 31%. Just for practice, because we're going to have to convert later on down the road. For B, we want to find the probability of picking a male. So again, what's going to go on the bottom of our fraction? 88. Okay. Of those 88, how many were male? 48. What's 48 over 88 as a decimal? Divide it in your calculator. What do we get? 0.55. 0.55, which is 55%. Next one, probability of picking a female. What's going to go on the bottom? 88 again. That's how many total people we had. Of those 88, how many were female? 40. And 40 over 88 is what? 0.545. Which is what as a percent? 45%. Okay. Again, the fraction and decimal are fine. I'm just writing it as a percent for practice purposes. You wrote it as a percent. That's also fine too. And they're not very picky how you write your answers, so I'm not even very picky on how you write your answers. Fractions, decimals, percents, all this stuff. Unless it's stated specifically how they want their answer to be answered. B says, if only a male is chosen, what is the probability of picking a student who got a C? Okay, so we're finding probability, so make our fraction. What's our total? What's going to go on the bottom this time? 48. Okay, we know we picked a male. We know a male was chosen, so we're only looking at the male population. And the total overall male population was 48. Of those 48, how many got a C? 13. And what is 13 about over 48 about as a decimal? What is it? 0.27? So again, about 27% chance of picking a male. Or picking a male who got a C. Questions over that? Not too bad. Again, it's just the basics today. We'll get more into more challenging stuff next week. Just the basics. Questions over that? If we take a look at the next section, we're going to talk about some more vocab. First vocab word from this second section is called a set. And a set is a collection of things that satisfy a well-defined criteria. So, a set might be people with their head down. That is a set. Okay? So all the people with their head down would go into that set. Okay? The well-defined criteria is people who have their head down, and anyone that fits that will fit into our set. Okay? Elements are the things that are in the set. So the things in the set would be the people who have their head down, and they shall remain nameless right now. I won't call them out, but you know who you are. But their names would go into our set. Okay, those are the elements. A subset is any set whose elements are contained within another one. Okay, so it might be those who have their head down. The subset would be of those people who are wearing a black sweatshirt. that would be a subset. So anyone wearing a black shirt would go into that subset. Okay. So looking at that more numerically, example 4 is set A. It's all the numbers greater than 0 and less than 10. Write out all the elements of set A. So I'm going to say A. So when we write out sets, we put the name. So whatever letter they give that set goes there. And then your list the numbers or whatever fits that criteria. So what are all our numbers that are greater than 0 and less than 10? Oh, what are you doing? 9. Very good. 1, 2, 3, 4, 5, 6, 7, 8, and 9. The reason why we don't put 0 and 10 is because 0 is not greater than itself, and 10 is not less than itself. Okay? So that is a set. We have criteria, numbers greater than 0 and less than 10. We wrote those numbers down in that set. You notice 12, 13, 14, 15 aren't in there because they don't fit that criteria. Okay. Example 5 says, given our set from example 4, sorry, that should be example 4, a subset B is defined as all the odd numbers from set A. So we're going to write out set B. So look at set A. What are all of our odd numbers from that set? 7 and 9. Okay. Yes, 11, 13, 15, 17. Yes, those are all odd numbers. Okay. But they weren't in my set A, so I cannot put them in my set B. I can only put elements from A into my subset B. Okay. Questions over that? No? Another vocab word is complement, which is all the outcomes that are not in an event or not in a set. Okay? In other words, a complement of an event is all the other outcomes, the ones we don't want. Okay? Yes. Right now, I don't want to stop teaching. We'll be done soon. You can wait unless you're like going to die. We often associate the complement with the word not. So if you're trying to find the probability of something not happening, that means find the complement. Okay? I also like to think of it's the opposite of what happened. So some examples is when the event is landing on heads, the complement would be landing on what? Tails. Okay? The opposite of heads is landing on tails. Okay? When an event is rolling an even number, the complement of that event would be rolling an odd number. The opposite of even is odd. This concept might be new from past math classes. Since all probabilities are between 0 and 1, the probability of an event and its complement will always add to 1 or 100%. Okay? Every time. Questions over that? Nope. So, if we look at example 6, says the probability of rain tomorrow is 40%. What is the probability of it not raining tomorrow? 60%. If there's a 40% chance of it happening, that means there's a 60% chance of it not happening, meaning the complement. Okay, so the leftovers also, that's how I like to think of it as well. One way of thinking about it, if you're stuck, we just said the complement and its event always add to 1. So if there's a 40% chance of it happening, you convert it to a decimal. If you do 1 minus 0.4, it gives you 0.6, which is 60%. Okay, so you can always subtract the probability of it happening from 1, and that will give you the probability of it not happening. Any questions over that? One more example. We have one more bell ringer after this, but it'll be fine. We'll just do it tomorrow. We'll double up tomorrow. A spinner is created with 3 equal sections. An experiment is run where the spinner is spun twice. Okay? Meaning there are 2 outcomes with each outcome. Okay? So when we do something more than once and we want to write out the sample space, we have to write it as a set of ordered pairs. Okay? So, I'll do the first couple and then you'll see the pattern. Our sample space is called set A. So we're going to say A equals. And again, when something's happening more than once, so we're spinning the spinner twice, or we spun the spinner 3 times. Alright? This is what your sample space is going to look like. It's like a list of ordered pairs. When you do this, it's really important to go in order. Don't jumble around because you're going to forget things. Okay? It's hard if you don't go in order. So I just go in numerical order. So if I spin this spinner on my first spin, my spinner can land on a 1. Okay? On the second spin, the spinner can land on a 1 again. So one possible outcome is getting a 1 on the first spin and a 1 on the second spin. That's one outcome. Okay. Then I'm going to repeat that pattern with getting a 1 on my first spin. So I could get a 1 on my first spin. What could I get on my second spin? A 2. I can get a 1 on my first spin. What could we get on my second spin? A 3. You repeat that pattern now. Now we repeat that pattern with getting a 2 on the first spin. So we can get a 2 on my first and then a what? A 1 on my second. A 2 on my first and then a 2 on my second. A 2 on my first and then a 3 on my second. So then how would the other one go? 3 and then what? 1, 3, 2, and then 3, 3. Right? I know some of you might be thinking, well, this one has a 1 and a 2, and so this one has a 1 and a 2, and that one has a 1 and a 2, right? But they're different order, so it's totally different outcome. Okay. So yes, they have the same numbers, but totally different order. That's saying getting a 1 on the first spin. This one's saying getting a 2 on the first spin. It's different. Okay. So that's the sample space. That is all the possible outcomes. Yes.
Do we have like order of that? Like, do we have like bigger columns that write a bunch of that out?
The most you will have to write out is probably 16.
What the? Oh my god.
That's not bad. I tell you, in college I had one problem that was like 10 pages front and back.
What?
Okay, yeah, not that bad. You have to write out 16 ordered pairs. It's not more.
Was it like tons of little questions?
No, it was one question. I had to write out a bunch of trees.
Oh, so your work took.
I worked for 10 pages.
Okay.
Yes.
That's a question.
Yes, it was a lot of writing. So writing out 16 ordered pairs, not that bad. There's worse things in life than having to do a little bit of math. Okay? It's not going to be that bad. That's like one time you'll have to do it. And you might do it tomorrow. Okay. So that's our sample space, all the possible outcomes. Okay, set B is defined as, so set B is defined as the spinner landing on doubles. So look at your sample space. Which outcomes had doubles? Yeah. 1, 1. Oh. 2 and 2, and then what's the other one? 3 and 3. So there's my set B. Okay. Now we want to find the probability of B. So we make our fraction. How many total possible outcomes did we have? 9. You go to your sample space. You count up all your ordered pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9. That goes in the bottom. Of those 9, how many were in B? 3. 1, 2, 3. What is 3 over 9 simplify down to? 1/3. So you can leave it as 1/3, or divide it and get 0.33. Anything that any of those 3 answers are fine. Okay. Well, what's the probability of not landing on doubles? Yeah, 2/3. Okay, there's multiple ways of thinking about it. One is if of it not happening means complement. So if there's a 1/3 chance that it will happen, I can just subtract that from 1, and that will give me the probability that it won't happen. Another way of looking at it is, well, if there's 3 out of the 9, but it will happen, that means there has to be 6 out of 9 that won't. And 6 over 9 simplifies down to 2/3. However your brain thinks of it. Okay? Questions over that? Yeah, there's one time I think where you have to write out 16. Generally it's like 9 or 6 or something. But it's just we can't ask you the same problem every time. We gotta vary things up a little bit. Okay? Questions over that? We'll finish up those last 2 examples tomorrow.